All right. Hello, everyone. Thanks for coming back. It's good to see you all. Before we get started, a little point of celebration. What am I talking about? It's May the 4th be with you day. I know you're all waiting for that, right? Star Wars Day and all that. So our background theme, for the most part, is Star Wars and Yoda and all that fun stuff. But all right. So you're probably wondering, what's left? What do we have to do? Well, this is our next to last lecture. So tonight we're in a pretty easy, well, of course, I drag you into an easy week, sequences and synonyms, and then I dump all this heavy work on you next week, and you only have 5 days. So fair warning, we will lecture next week. I'm going to talk about the final project. Don't panic. It's just, and if you need some pointers, just talk to Garrett. He's already done it. And it's just basically building this kind of isolated schema, but it's just you're adding all these things to it. Just follow the cheat sheet, and I'll outline it today, and I will outline it next week as well. So be prepared for that. And it's just basically building out some things in the SQL developer, and then showing me your work. So next Monday is our final lecture, May 11th. There's a lot to do next week, but not as much as you think. Yes, we have the final. Yes, it's a big 100-pointer, but it's 50 questions. It's the last part of our semester. It's not a complete semester worth of material. Along with that, and primarily what we're going to do next week, it's not really a full lecture. I'll talk about the privileges, regular expression, and TCL, but that's kind of additional information to add to your knowledge base. We have the final. Yes, you do have a final since it's final week, and the final project and this last assignment, but it's no big deal. So next week, what I'm going to do is just talk about the final, talk about the final project, continue that conversation, talk about the final. Final is very much like the midterm. It requires respondents lockdown and all that. So if you did well in the midterm, which most of you did, remember our average for the midterm was high 80s, 87, 88%. So be prepared for the same types of questions. And there's a study guide, etc. So not anything that should surprise you from that perspective. And that's it. So next week we have module 14. No big deal. We'll probably cover most of the material. Very short lecture, or maybe a long lecture. I don't remember. But anyway, it will be our final week. So please prepare yourself for that. And that's all we have left. And then it's off to your summer, and I will be preparing to take a little bit of a break. Although, anyway, but it's been quite an adventure with you all. And yeah, and I don't say this how many times have I taught this class? This is probably my 5th year teaching this class. So you guys are the best students ever. Yeah, there you go. Pat yourselves on the back. Feel very comfortable that, yeah, I haven't had any major issues, so that's always good. All right. So, and technically the last day of the semester, please make a note of this. If you have extenuating circumstances or whatever, I will accept work after, but I need to have all the grades done and posted by, I try to get it, I'm actually on my way to a conference next weekend. So I'd like to get everything done on Sunday morning at the latest. But our last day, the official last day of the semester is the 15th. And that's next Friday. Does that make sense to everyone? Next Friday. This Sunday, make sure you call your mom. Those of you that haven't talked to your mom, it's Mother's Day, so at least call her and say hi, Happy Mother's Day, right? Or send her a card or send her a flower or something. All right. Okay, I'm not going to review. Does anyone want me to review module 12? I didn't, I took that out of or did I? Oh, I didn't. Well, do we need to review module 12? I have my slides backwards, but anyone want to review? Anyone need a review?
Good
Think
on it.
about. Go ahead. Yeah. No? Yes?
No.
Yes? No? All right. There's a lot of hesitancy here. All right. Let's see what we got. Let me check to see how poorly. I'm not going to show you this. I can't show you the grades. I'm not allowed to do that. But I think everyone did mostly a good job. Let's see, module 12. Yeah, a couple of people missed, but yeah, maybe I should go over the quiz. Let's see. Yeah, I'll go over the quiz, but for the most part, everyone did fairly well. So I don't see any major issues there, but I will review it right quick here. All right. Module 12. Let's back up. Scroll down. All right, the quiz. Okie dokie, let's preview it. Okay. Which of the following statement is a valid reason for using a view? Remember, views are like little windows. Views are not valid unless you have more than one user. Views allow access to data because the view displays all the columns from the table. Views are used when you only want to restrict DML operations using with a check option. Possibly. Views provide data independence for infrequent users. And who made up these responses? Yeah. They're really kind of dumb. But anyway, one view can be used to retrieve data from several tables views. So obviously the longest answer is the correct answer. It could have been either one of those, but D was the correct answer. All right, which of the following DML operations is not allowed when using a simple view created with read only? Oh, insert, update, delete. Well, all of those. So if you create it with read only, you can't do any DML. Yeah, so don't try it. What is the purpose of including the with check option clause when creating a view to make sure that data is not duplicated? Ensure that no rows are updated through the view that would prevent those rows from being returned by the view in the future. Yeah, okay. I think it's Bravo or B. So you basically want to make sure you're not creating any integrity issues with the data. Hence, that's why you use a view anyway. All right. Number 4, last one. You administer an Oracle database. You administer it. So you're the DBA. Why did I? Yeah. Anyway, sorry for making that so confusing. Jack manages the sales department. He's the sales manager, which they're always a pain. He and his employees often find it necessary to query the database to identify customers and their orders. I would absolutely say no, get away from me. Don't even bother. I'm not going to let you query the database. And they get all huffy. But he asks you to create a view, and they've done that to simplify this procedure for himself and his staff. The view should not accept insert, update, or delete operations or DML. Which of the following queries should you use? So which one do you use? Oh, I think this one was, there was a lot of points for this one. Create view, sales view as select company name, city, order ID, order date. For a customer with read only. Ooh, I would definitely have it with read only in there. So which one, A, B, or C? What do you all think? Who wants to volunteer an answer for that question? I think everyone got this right. So what did you choose? Let me know which one. You probably don't even remember. Do you remember?
It should be C.
Charlie, did you say C there? I'll say
Yeah.
create view, sales view as like company name, city, order ID, order date, and total from customers and orders. You have a little join there where customer. Oh yeah, I like that. They'll definitely see. And I think no one got that wrong. So And why, okay, why would you choose C? Who wants to briefly explain? Putting you on the spot. Anyone? Anyone? No one wants to explain. Come on.
Because isn't it because it has as before select?
Well, A has asked for before select two. Why not A? Yeah, Bravo's completely
Well, because
wrong.
A doesn't have the C dot city or whatever.
Yeah, these are both syntax issues. You all see that, right?
Yeah.
They're syntax, so you get an error. And whereas Charlie has no syntax issues, so they're all basically the same, right? You don't really see a difference, but these are syntax, so good job. All right, there you go. Good job reviewing. Now we're going to go right into sequences and synonyms. One of those additional topics that's, is it important to know about sequences and synonyms? It has its usage, but not at a very high level of importance. But this is Oracle Academy now, so we want you to know this information. So, excuse me. So our objectives listed these three valuable characteristics of a sequence. Write and execute SQL statement that creates a sequence. Create a data dictionary, our fun place to find information about our objects. Apply the rules for using next val. That's kind of important to generate sequential unique numbers in a table. Sometimes that's useful. List advantages and disadvantages of caching. Remember, caching and just creating a historical or storage or some type of temporary storage whenever you see the term caching. Name three reasons why gaps can occur in a sequence. And if you're creating a sequence, although I'll let you know that this was the way to create, a numbering scenario in the old days. All right. All right, so our purpose. So can you imagine how tedious it would be if you had to enter 30,000 names? And we just had a marathon here recently. It was the Boston Marathon. And I think they had probably that many runners as well. So who entered the London Marathon in the database while making sure that no one was given the same ID number? Yeah, there were a day probably when they were all handwritten, maybe, I don't know. I'm thinking at one point. So what if you went to lunch and when you returned, someone else had entered some of the runners' applications? How would you know where to start? Fortunately, SQL has a way for you to manage that, and it's called a sequence. So the sequence is another object in your database. We already know two other objects, table and a view. The third database object is a sequence. It's a shareable object, just like any of the others. So typically you'll have multiple users calling a sequence. All right. So remember, primary keys must be unique. For each row, the sequence is generated and incremented. And this is a good way to manage a large database like, runners in a marathon. It is a way to save a lot of time just to create this, and it's just a counter. Typically, it just counts unique instances for a record. So here's the syntax. Got a good old create keyword, create sequence, and then the name of the sequence. And then there's criteria, and I'm going to go over all these. Increment by, start with, max, min, etc. And you're wondering, what is all that? So the sequence that's listed up here is the name, increment by, and you're all smart. That means that's what you're going to increment the sequence by. It will default to 1. Start with, and usually you want to tell it what number to start with, and basically it will start with the number 1. It's not like an array. It will start with number 1. If it's omitted, if you don't have a start with, it will default to 1. The max value n is the max value that it will count to or increment to. No max value, then there's basically it goes to almost forever. 10 to the 27, if you can count, probably take you quite a long time to count to that number. But yeah, you can eliminate and just have no max value. And that does occur sometimes. You just want the sequence to go on forever. The min value, basically the minimum value of the sequence. So you can have a minimum value. Basically, it has to, start at that minimum usually. And you would think, well, wait, that doesn't make sense. But what if you want to essentially create something in descending order, and that's where the no min value comes in. Rarely happens that you have a sequence that you're doing something like that, unless there's some type of arithmetical something that applicable on that realm. All right, but you do have a min and a max value in there. All right, cycle, no cycle. Basically, yes, you got it. Either it's going once it reaches the maximum value. If you have cycle on or enable, it'll cycle around and begin the count again. You have it off or no cycle, then it just, you don't have, basically, it does not cycle. And then cache and no cache, not a big deal anymore, but back in the day, we always had to worry about memory, amount of memory, basically, and that's the same thing that you use in websites, and if you're a web developer, you cache some of the sites. But basically, it's used to temporarily store information, just in case there's any type of crash, but not such a big deal anymore. But you can set that in an Oracle database, the cache, no cache. And you see it caches 20 values. Is that useful? Possibly. All right, so that's the syntax of your general sequence. So if we use our London Marathon, and basically we're creating a sequence to count the number of runners. So we're going to call this sequence runner ID. And yes, there's a naming kind of convention for that. Increment by 1, start with 1, max value 50,000, no cache and no cycle. So we want to make sure all of those runners have unique numbers. So it is tradition that the most unique runners have those lower numbers, like the winner of last year will be number 1, etc. So this is just alluding to that whole concept if you're storing the runners in your database. No cache option prevents values, and you will see this on an exam in the sequence from being cached in memory. And basically, the reason why we're mentioning this, or why I'm mentioning this, there used to be an issue with the number of, allocated memory for records in a database. I mean, generally, we would have shared memory, et cetera, but you do need to know that if you're going to be, have any type of database administrator on the technological side. But just remember that you probably won't run into resource issues. And once again, the no cycle and cycle. In this case, we have a max value of 50,000, and usually you don't have more than 50,000 runners, but we want to put no cycle on that because we don't want the numbers to repeat. Simple as that. All right, you can confirm a sequence. You can verify that it was created. Just look in the user's object. Everything is in that user's object data dictionary, as you all discovered. You just have to indicate the type. So this query here, select sequence name, min value, max value, increment by last number from user sequences, and there you go. You can see all the sequences that were created, the name, the min value, the max value. Well, who created this sequence? That's a pretty large number. Employees, they're expecting a lot of employees. Well, anyway, let's hope it doesn't reach that. Well, they're only up to 207. So that's anyway. Well, I talked about cache and no cache. I do repeat myself a lot. All right. So we do have these pseudo columns in a sequence that you need to be aware of, and you can probably figure out what they are. Next val and current val. Next val is a pseudo column that's used to basically tell you what the next value of your sequence is. Current value, you figured it. The current value, if you list that as a pseudo column, it'll tell you the current val. So let's say you want to, and pay attention to the syntax of these. You'll be running these if you wanted to figure out. So insert into departments, department ID, department name, location ID in this example here. Values, department sequence. We're using a sequence now, and we're indicating the next value that's available for that sequence. And the syntax is just that. Department sequence dot next val. Does everyone understand that query? That makes sense? Yeah, simple as that. And so if we had a sequence, which we do, as you saw in the user dictionary. All right, so suppose now we want to hire employees to staff the new department. We just created that new department. So we would do something like this, insert into employees, employee ID, etc. And we would use that employee sequence. That's tab 2. A little bit different than this. This is an employee sequence, and we're putting the next val. So we're getting the next value of the employee ID, right? And we're putting that employee in the current value of the department. All right, that can be a little bit confusing, but we know that the department ID, we know the department location ID. Oh, yeah, we just want to make sure that this new employee goes into the right department. You probably can figure out in our simple database what the department is, but in case you have a large company, et cetera, you want to use the current val, next val, pseudo columns. And they're not actually columns, which is why they're called pseudo columns, but they're listed in the system when you build a sequence. And you have to be very careful. You can always query these to make sure which is which. And as long as you use the syntax here, the dot syntax, so the sequence name dot curval dot next val. All right. So I go into this in a little bit more detail. So after you create a sequence, it generates these numbers, and well, to sum this up, basically you can indicate essentially where the sequence is based on these particular pseudo columns. There's places where you cannot, well, what I want to illustrate here, you can use next val and current val in the following context. The select list of select statement that is not part of a subquery, so you can't use that in a subquery. The select list of a subquery in an insert statement, the values clause of an insert statement. This is where you can use the next val and current val. The set clause of an update statement. So update, set, yeah. And you have to use that syntax that I indicated before, where you cannot use it, the select list of a view. So don't use next val, current val in a select list of a view. And there's a reason. You can kind of figure that out. The select statement with the distinct keyword, once again, that really wouldn't make sense. The select statement with any type of group by having or order by clauses for the grouping functions. Once again, why would you need to use that? Basically, don't use these particular pseudo columns in subqueries. It just makes it easier to understand what you're attempting to accomplish. The default, so in the default expression, remember when we created a table, don't use these pseudo columns for the default expression. Right, so to continue our London Marathon example, we created this table called runners, right? So now we created a sequence, right? And we runner ID, which is our primary key, first name, last name. So that's kind of a start of our table. So we haven't really identified where we're going to use the sequence, but I'm thinking that it probably will be in that runner ID. So we'll take that sequence and use it to insert our runners. And you see how we're using it here. Insert into runners, runner ID, first name, last name, values, runner ID, sequence, next val, and then their name. So that's how you would do that. Of course, something like this would be automated with some form, but the sequence has already been created, and then you don't have to worry about the numbering. in your database. So there you go. That's how we would use that sequence in that London Marathon example. Right, so you can view essentially where the count is by running a sequence like this. We use our dual table, select run ID sequence.curval. And you see here from our example, we know it's 2, so there you go. Remember, curval is just a pseudo column. More about caching. It's not, as I said, it's not such a big deal anymore, but because we don't really have memory problems, but I have to say Oracle wants you to be aware of that. All right, non-sequential numbers. Although sequence generators issue sequential numbers without gaps, this action occurs independently of a database commit or rollback. If you run across a gap, or you can create a gap by doing a rollback, or if the system crashes, any of these particular items, if you don't have a way to control the way the sequence is being used. For example, and I mention this because this could be a part of a form that's automated on a front end application or whatever. And let's say the front end crashes and those queries, now you have a gap. Usually there's a backup scenario and you don't really have to worry about it, or you can simply do your own manual rollback. And if you don't have a cache, and that's not really a big deal anymore, but basically what a DBA will do at this point would take to see where the sequence is, see where the gap is, and then it takes just a few seconds to recreate the numbering if it's a part of an application or whatever. So that's usually not a big worry, but anyway, so if you need to modify a sequence, so as with any of the other objects, you can use the alter statement, alter sequence. Of course, there's some rules, and we'll get to those. Generally, you don't want to alter the max value to be lower than the initial because that creates issues. But in this case, we wanted to alter our max value, our little runner sequence from 50,000 to 999,999. I don't know why we would do that, but that's how you would alter that sequence. So as I said, there's some guidelines. Only future sequence numbers are affected by the alter. So if you've got 1,000 runners registered, if you alter it, of course, usually just alter it. Most of the time you're altering a sequence to increase the max number or something like that. But remember that only, anything after the alter, just with any database object. Removing a sequence, yes, our magic word drop. So you can drop it. Basically, it doesn't really impact anything because it's an independent object for the most part. All right, sequences can be useful, used for incrementing a counter or whatever you want to look at it that way. And you will be running through some exercises with that. So some of our key terms: cache, no cache, create, curval, cycle, increment by, max, min, next val, no max, no min, the sequences themselves, and start with. You're all ready to take on a sequence. And yeah, sequences they're simply used for the most part to make numbering, something like a big event or whatever, a lot easier. All right, on to section 2, indexes and synonyms. Define an index and its use as an object. These are objectives. Name the conditions that cause an index to be created automatically. And yes, please pay attention to that. Create and execute a create index and drop index statement. Create and execute a function-based index. It's a little bit different. And create private and public synonyms. Synonyms, that's thrown into this section. Synonyms are useful. Synonyms, and yes, it does follow that word as far as the definition. It's synonymous for something. So remember that. All right, so can you imagine going to the bookstore or library and finding all the books stacked on the shelf in whatever order? So, and this example, so how many of you go to the library, check out books anymore? Anyone? I do. They do have a few books left, so not everything is digitized. So they have what's called a Dewey Decimal System, right? They know, so indexing is very similar to that system. And basically, indexing makes it easier for the database to run your query and find your data. And yes, there was a time, even during my lifetime, where there was no indexing, and it was really hard to find data. So much like the internet, like the web addresses, basically you have the octets, and it tells you exactly where to go. Indexes are very similar to that. So the Oracle Server Index is an object, and basically its main purpose is it actually creates a pointer from your programming. If you're a programmer, it'll point to exactly where your object is located. You can kind of get a sense of where I'm going with this. Indexes are very important. This is definitely connected to the keys, the primary keys, the unique keys, and all that. So please remember that. And I hope I didn't just skip over that. So the index is maintained automatically by the server. Once an index is created, no direct activity is required, so you don't have to do anything. Row ID and base 64 string representation of the row. You don't really need to know that, but that could come up in a certification exam. Indexes use row IDs because they're the fastest way to find your record. They're logically and physically independent of the table. Yeah, please. This means that they can be created or dropped at any time and does not impact the table. So when you drop a table, corresponding indexes are also dropped. All right. There are two types of indexes that can be created. Unique index. The server automatically creates an index when you define a column in the table. That's a primary key or unique key. There's an automatic index created. Remember that. The name of the index is given the name is the name given to the constraint if it's a unique key constraint. So this is how the system creates indexes automatically. Whenever you create a primary key, automatic index. And then there's a non-unique key, something that you would create manually, like when you create a foreign key that references a primary key, it's also creating an index, which helps. Basically, the indexes help in the organization of finding the data. So we all have to create table privileges, so you can create indexes. You can create indexes on your schema. Indexes cannot house a null value. All right, for example, to improve the query access to the region ID WF countries, we would create an index following the syntax here. Create index, WF country, region ID. That's the name on WF countries, region ID. Done. You create the index on that column. That's a table, WF countries, right, and a column. Index created. All right, so there's times when you should create an index and times where you shouldn't, and it does make sense here. So you should create an index, and yes, this is actually in the formula. The column contains a wide range of values. So the column itself, the column contains a large number of null values. Yes, you do actually want to create an index if you need to. One or more columns are frequently used together in a where clause in a join condition, so you can create an index around those. And it's usually the primary key, foreign keys, and that would make sense. The table is large, and most queries are expected to retrieve less than 2 to 4% of the rows. So if it's a large table, meaning many columns and many rows, which you rarely find in a relational database situation, but you will find a table with maybe millions of records. So, and this is why you create a primary key. Okay, when do you not create an index? So when deciding whether or not to create an index, more is not always better. So don't ever create an index on more than one or two columns. I'll just give you that kind of clear warning. So each DML operation basically looks for the index, and if you have several indexes, then you're actually defeating the purpose. So that's the caveat to it. So it's not worth creating an index. So if the table is small, like our little schema, yeah, we're creating indexes, but you don't need to create indexes when you have 20 records with 5 or 6 columns. The columns are not often used, so it's kind of the opposite of when. Most queries are expected to retrieve more than 4% of the rows in the table. You don't really need indexing if your select query is going to retrieve a lot of data. The table is updated frequently, and this is the one thing that does happen a lot. If you have a table that's always being updated, basically you don't want to create an index. And you're probably thinking, wait a minute, is that kind of counterintuitive? Kind of. But usually an index is used to find records. So if you start running DML, then it can possibly hinder. And then index columns are referenced as a part of an expression. Once again, that doesn't seem quite right, but well, to be kind of frank, I mean, indexing is useful when you have large tables, etc. The resources now, it really changes kind of the whole idea, but you should have a primary key that starts the whole indexing process in a relational database. Okay, so there's something called a composite index, and basically it's composite and sometimes called concatenated. In a nutshell, it's usually multiple columns. And you see in modern relational database, you always see a composite index, some type of composite indexing. It's usually something like maybe last name and phone number, something that would make sense to be indexed. And here with a composite, it usually involves, well, 2 columns or more. In my experience, I've mostly had a student ID. What did I have? Student ID, and I don't remember if it was last name. I remember I had to create it that way because there was far too many students with the same name, so I had to combine the ID. Null values are not included in composite, so you need to account for null if you're going to create a composite index, which can be pretty complicated. So to optimize, you can create an index on the foreign key column or another column. Generally, if you have a primary key and it's a pretty simple table, you more than likely will not, because that primary key is going to be unique with null nulls. You probably do not need a composite, but as a database administrator, you may have to research that. All right, so that's composite indexes. I haven't seen a lot of those in the last 25 years, but when I started out as a DBA, yes, I would use them a lot. Okay, data dictionary, you can also check. Yes, you can check your indexes to see what columns are indexed. So if you run a query like this, select distinct IC index name, IC column name, IC column position, ID uniqueness from user indexes. Yes, that's our table user, and we're joining user index columns. So there's an organization within the Oracle where the indexes and the columns are organized in 2 different tables. Where ID.table name. So basically, we're doing this join, kind of a join on 3 tables. And you have the index name, the column name that's indexed, the column position, which is usually the first position, and then its uniqueness. And yes, you will have indexes. Now, we're not talking about primary key. You notice the primary keys are always unique because that's a condition. But you have some other, like email is a unique, and it's also indexed too. And with the rest, last name is usually unique, but we have 2 last names here, depending upon what table. So if you ever want to, this query is very useful. You want to see what indexes you have within your schema. Of course, you would probably want to organize that so that you can determine its usefulness. All right. Function-based indexes store index values and uses the index based on a select statement to retrieve data. Function-based index is an index based on expressions, and I'll show you this in a minute. The index expression is built from a table, columns, constants, SQL functions, and user-defined functions. We probably won't see. Matter of fact, we won't see a lot of that. Function-based indexes used to be a big thing because it would be a procedure that you can run that will index based on a criteria. We'll call it that. And basically, you use them when you don't know what data is stored, but you're given a scenario that requires a certain response or a certain result. So, for example, you can create a function-based index that can be used with a select statement using upper in the where clause, upper to make everything uppercase. So if you do something like this, basically, this is a function-based indexing, and we're just making the last name in our employees table all of the last name uppercase. First, it would match some type of scenario. So that's why it's called function-based index. And you see here, keying is now. If we had a query and all upper for some reason in application, it would bring back the correct data. So function-based upper and lower two functions, and that's where you would use it. It just makes the whole selection easier based on. Usually, it's based on some type of front-end application. Nowadays, in the old days, it was based on data entry, etc. So if we're concerned about case sensitivity and all that, we can create a function-based index, and it would bring back everything based on, and it will not be based on the case that's stored in the database. That's the whole idea. So to ensure Oracle uses the index rather than performing the full. So, and that's another thing, I didn't mention this, although it's not a big deal anymore. If the table is not indexed, whenever you run a select query, it will do a full table scan. That was the old days, and it would take forever for a simple select query because it's scanning the whole table, all the rows, all the columns. So then this is what indexing will do for you. It will find the index and find the order and basically point to what you're searching for. All right. All right. So I just pointed out upper and lower. Remember, upper and lower just functions in Oracle. Here we're using a function-based index to find employees that were hired in 1987. So we've seen this before, so that should not be a surprise. Once we create the following, we can run the same query, but this time avoid. So yeah. So that's just representing the whole, eliminating the whole full table scan, and it's much faster, especially if you have many records. All right, removing an index. So you cannot modify indexes. I mean, there's no alter index. You have to drop it and recreate it. Remember, indexes cannot be altered. Just the way they're, stored as an object. There's a reason for it. We're not going to get into the entire reason, but yes, you have to drop it and then restore it. So to drop an index, drop index name. You've seen this before. All right, synonym. You're probably wondering, well, synonym, I've seen that word before. So in SQL or SQL, synonym is just a word or expression that you can substitute for another word. It truly is. Without going to all the details on this slide, basically, if you want to rename whatever object to something that you could probably remember, as you see this system created name of this table you can use a synonym. You can't really change the system name, but you can use a synonym to point to the same object in the Oracle database. So what a synonym does, basically, you don't have to divulge any complicated system names or any naming convention. You just create a synonym. It becomes, usually it's a DBA. It becomes accessible by any user as long as they know the synonym. And a DBA will normally add requirements or limitation or constraints based on the synonym. So, and the keyword public, so when you create a public synonym, then everyone can use it. But you can create a private synonym. I think I go over that. So the syntax, create public synonym and then the synonym name. And then for object, identifies the object for which the synonym is created for. All right. Create public synonym, the name, and then the object. So I'm creating a synonym. I'm calling it Dwight Imps, and then the object is employees table. So, and that means that anyone can access either of those tables, or maybe we restricted the employees table. We don't really go over packages. If you continue in the Oracle Academy, it talks about packages, several transactions, and I'm not gonna, but as far as the guidelines for synonyms, it cannot be contained in a package. So the package is kind of many queries in one little, that it will do a certain thing, but we're not going to go over that. A private synonym, a name must be distinct from all other objects, just like any other object. But those are typically the guidelines. If you don't, violate any of those guidelines, you can create a synonym for any object. Remember, any object in your schema. All right, so to remove a synonym, yes, the keyword drop, and then you have to indicate whether it's public or private, the synonym name, synonym, and then the synonym name. So then we just drop that synonym that I created. All right, confirming a synonym, yes, it's in the user dictionary. If you query the user dictionary, you can see that all the synonyms, remember, a synonym is just a name that you're substituting for another name. It's pretty simple. I didn't really talk about private synonyms. It's not, I think we removed that because Oracle's restricted that to another level of consideration. So if you create a synonym, well, I don't want to say synonym. It's always public, and it's just a name that you can easily be aware of, etc. And that's it for tonight. So what I like to do now, once again, let's go through the Mod 13 quiz together, except for, I think Garrett already did this. And then after that, I'm going to do kind of a final project overview as you prep for our last week. But the first thing I like to do, yes, we're going to Kahoot the quiz, and it's the same options. You can either take your Kahoot score, or if you're not pleased, the questions are basically the same, but I had to shorten them a little bit because there's some restriction. But this way, if you if you let me know that you don't want to use your score from this collaborative quiz, then basically you can go back and redo your quiz score. But this is my way so we can have some fun, right? All right, so please join the Kahoot, and this is the Module 13 quiz. Same questions for the most part. So and you can tell me whether thumbs up or thumbs down, and yes, there's some rewards if you make the podium. So if you make the podium, you're automatically exempt from the quiz, and you get a full score, no matter how poorly you do. I know you're all saying we're all going to do great. All right, everyone, please join. Let's see who's not in. Matt, Frank, you guys awake? I promise there's only 8 questions. Evan, Daniel, yeah, Eric, Matt. Who else is not in? Daniel's in. Frank, are you going to be with us? Richard's in. Jose's in. Garrett's going to probably win. If Garrett hits the podium, since he already took the quiz, so we'll take the 4th place for the reward. All right, here we go. This is all Mod 13. Well, it's the Mod 13 quiz. So, which of the following is true about row num? Oh, I got a lot of you on that one. It's the number assigned to each row returned by a query on the table. Yeah, this one did look after it's ordered. Doesn't have anything to do with ordered. Oh, wait a minute. Is that right, Garrett? Or did I get that one wrong? Okay, let me check. I may have to give you all credit for that one. Because I just created it. Hold on. Give me a second. Quiz 13, module 13. I have to check my work. 1. Pronoun. That should be, it's the number assigned to each row return. This is read from the table. So yes, it is 2, not 1. Oh, that is pretty tricky. Yeah. I know. Sorry. My quizzes are, try to clean them up too. Okay. All right, let's continue. Which of the following best describes the function of the curve-val virtual column or pseudo column? Wow. I guess I didn't go over this clear enough. So it's the curve-val virtual column which displays the integers supplied by a sequence. Most everyone curve-val virtual column would enter the sequence by specific. Yeah, I guess that could be right too. So I will be lenient, but the red is the most correct answer. So I think you're all guessing now. You need to retrieve the next available values for the sales index sequence, which would you include in your SQL query? Next available value. This one should be easy. I know you're all giving up now. Yes, next val. Good job. All right, now we're getting some traction. which of these keywords is typically used with a top-in analysis? I didn't really go over this one. The correct answer is sequence. There you go. All right, evaluate the query. Drop sequence line item. What does this query do? This one you should know. Yes, it removes the sequence from the data dictionary. Drop. All right. Oh, how did this get to be multi-select? Which of the following queries best describe the indexes and their use? This one was not supposed to be multi-select. Oh well. But you guys, none. Well, that's not right. Obviously, I messed that one up. So it's anyway, I'll give you all that one. That one's, it should be, they contain the column value and points to the sorted table data. Yeah. Sorted table data. So gold was most correct. Why I screwed that up. I shouldn't make these the last minute. Barry creates a table named inventory. Pam must query the same table. Which of the following should Barry create? Yes, there should be a synonym because the others don't make sense. He doesn't have to create a whole schema. Sequences, yeah, synonym. All right, last one in this crazy quiz. All right, double points. Employees table contains those columns: imp ID, primary key, first name, department ID, hire date, salary. The index is auto-created where? All right, yes, whenever a primary key is created, the index is auto-created. So, all right, that's kind of a wacky example. I'm sorry, I kind of confused that some of the responses, but you guys did well in spite of, so I appreciate that. All right. So, see, Daniel, Jordan, and who is fourth? Because Garrett doesn't count. He's already taken the quiz. Who is fourth? Speak up.
I don't know. How do I see that?
It was Jose.
I
Okay,
can,
Jose.
I can see it. Who's well. All right. All right. Let me take a look. Okay. Report. All right, fourth place goes to Jose. So Daniel, Jordan, and Jose, you guys get full credit for the quiz. Everyone else, now that you've had a preview of it, sort of, please complete the quiz. So I say Daniel, Jordan, and Jose. All right. Whoops. Thanks for divulging me with that mess. Okay, let's do a quick overview of what's expected for the project. And remember, the project basically is due the 15th. So I would just finish this easy week. You can start on it this week, but I'm going to give you kind of a quick overview here if I can find my, all right. The project is worth 40 points. It's in the last, in module, a part of module 14. I will review it again next week. I do have an overview video that I created last semester. You can view that. It'll give you an idea of what I'm looking for. But please review that. And the final project outline, where's mine? Let me make sure. You have a bunch of queries which creates your tables and your requirements for the tables. So basically you're creating a movie streaming service. So go through those, follow those instructions. I check all of that you've created all those objects. And it includes the sequences, the tables, and you have to add data to the table as well. So that's kind of the first cheat sheet. And then there's a second one, which basically has everything that you need to run. But don't just copy these I do need to see that you're running these in SQL Developer. It's giving you everything you need in this document, but you have to run them successfully in Developer and provide me with all of the screenshots. All right, this document here gives you, everything that I'm expecting. All right. And then there's some guidelines as far as what I'm looking for: tables, adding the constraints, creating views, creating sequences, adding data to the tables, creating indexes, creating synonyms, and then testing the database is basically a select statement of one of the tables. Now, when I say I used to require the students create a scenario, but it's the same thing. You need to make sure you're going to be adding data. You need to make sure everything is following the requirements as far as what's the information that I'm looking for within the project. So once again, it's just a matter of following these two documents. So you're creating basically you're creating a customers table with these columns, and movies table, and then all the information that goes with this streaming service. All right. And these two documents are basically all you need to run, but I must see that the documents have been ran in SQL Developer. That's the key. That's where you get your credit. It shouldn't be that hard. Nothing too difficult. Just make sure that you provide all the information that I'm asking for when you submit it. When you submit and as I said, it's due on the 15th. It is open now. I opened it up this morning. So you have 2 weeks to finish that, along with your module 13 is real easy. I think the assignment, we're going to go over that here in a second too. Any questions about the project? Make sense? No big deal, but I must see your work. This is one project where it basically is all about checking all the boxes. And it's really,
Yeah, I was gonna wonder, you want screenshots and stuff, right?
yes.
all this. Yeah, like all of our assignments. That's what I was thinking.
Yeah, just like you've done before, all those requirements.
And you said, and the way you looked at it, it seems all the instructions of what we're supposed to do is laid out. So as long as we can show all of our work and we follow those instructions, we should be good.
Yep, it's all about following the instructions and showing that you've actually performed those. That's the key. You're
Okay.
becoming a DBA.
That's
Right.
fair.
All right. So it's a little bit of work. Garrett will tell you it takes a little time, but I'm putting him on the spot because he did it already.
I mean, if it were open this morning and he was able to do it this morning, I'm confident I
Yeah.
can get it done in a reasonable amount of time.
Right. So it's not too bad. All
Doesn't
right.
sound like it is. I was a lot more afraid of it when I first looked at it.
Yeah.
But then again, I didn't have access to the assignment. Now I get to
Right.
see the whole thing.
Right. So that's the project. As far as module 13, here's your practice queries, and then your there's additional resources coming right from Oracle that talks about indexes, the usefulness of indexes. I would read through that. It'll definitely help you on the final. And then your practice and solutions definitely will help you on the final. Please don't skip over this. Sections 1 and wait, did I get these backwards? Okay, 2 then 1. I should straighten that out. But anyway, practice and solutions. I don't know how that got backwards. And then the assignment, just 1. And you're all used to this, just 4 questions, no big deal. You're creating a sequence, etc. And then the quiz basically, yeah, I know the Kahoot was a little wacky, but who gets the free pass on the quiz again? Jose, who's on the podium? I forgot already. Jordan,
Yeah, and I think Daniel was
Daniel?
number 1.
Daniel, Jose, and Jordan. All right, and that's it for this week. I'm going to make sure I mark those down. Let me stop sharing so I don't forget. So I would suggest you have your marching orders for the project. Just get started on that. You don't have to do it all in one sit, but and remember, we have our lecture. The final will be open. I think I'm opening up that first thing on Monday. So basically, if you're an overachiever, you can get most everything done before even lecture. And maybe we'll just have a little party. I don't know. A little virtual party. How's that sound?
Sounds good to me.
Play some music. Don't really. If you have any questions about the project, just ask. The last assignment is a lot of that you're not even going to be able to run on the SQL developer. It's just informational only. Or you can bug Garrett. He's the designated TA now since he's done everything. And just go or Maria. I think she's working now. So anyway, any last minute questions?
Nope.
For the final, it said 1-page note, so we're restricted to 1 page.
No, you can do whatever you want, except run anything on your computer while you're open.
Sweet.
Yeah, same as a midterm. It says that because I have to say that. So you can't write on your hand or bring it. No, use your phone. No, it's wide open. Is that why you all did so well? You had very, very copious notes and all that, right?
I mean, I made sure I had a lot of good notes before I went in.
Okay.
Yeah.
That helped a lot. Just so that if I have to think twice about something, because sometimes there's some that look close, I have something to reference and go, okay, that this is the most correct to the syntax that I have here that's similar. So
Right. So yeah, yep, there you go. All right. Let's see, Daniel, Jose, and Jordan. Okay, you guys got credit for the quiz. All right. That's it for tonight. Remember, one last meeting. I'm really not planning on lecturing. Just going to go over the project a little more, see where you're at, and talk about the final. That's it. And then we'll have a party. virtual party. So bring your party hats. Party hats are, and then, yes, everyone will have to open their cam at least for a few minutes.
All right.
Those of you that are hiding behind your name. But thank you all. It's been a great semester. So just finish strong. I don't think anyone's any major problems. And once again, if you have any issues with the project, just let me know. Don't make a big deal out of it. It's not really a big deal. But make sure you're showing all of your work. That's the big thing about it. Screenshots, screenshots, screenshots. All right. Okay. I will see you all next week, our last hurrah together. And then I'll release you for your summer. All right. Take care, everyone.
Later,
All right.
everybody.
Thank
Have
you.
a good night.
Have a good night.